In this video, we will do a very simple activity. We have a sheet of paper and we have some toothpicks. On the sheet of paper, we will make parallel lines where the distance between the parallel lines is equal to exactly twice the length of one toothpick. And then we will proceed to randomly throw the toothpicks onto the sheet of paper. Now, the interesting thing about this activity is that when we throw the toothpicks on the sheet of paper, some toothpicks will not cross the parallel lines, some toothpicks will cross the parallel lines. Now, I will attempt and make some sort of prediction about the ratio of toothpicks that cross the parallel lines to the ratio of toothpicks that do not cross the parallel lines. And I predict that the ratio will be somewhere between 3 to 3.4. Now, we shall do the activity and then we shall try and figure out whether my estimation is correct and why it is correct. So as we can see, we've dropped 56 toothpicks and 19 of them are crossing the line. So the ratio is approximately 3.1111. So it's a very close estimation, and we will now try and figure out how that ratio comes out to be and how I could estimate it. Before that, let us try and understand a few concepts first. So now we will try and understand what probable value means. Probable value is basically the average over infinite observations. So for example, if you throw a dice infinite times, then the probable value will be 3.5. Now this doesn't belong to the set of values that can happen, but like we said, it's an average over infinite observations. So it would essentially be summation of x fx divided by summation of fx, where f is the frequency of a particular event happening. So 1 appears f1 times, 2 appears f2 times, and then you multiply all of that and then you divide by total number of frequencies, and then you get the probable value. And if you do this infinite times and for a dice, that will come out to be 3.5. Another concept that is very important is suppose we throw one matchstick on a sheet of paper with the parallel lines as we did in this experiment, and we get say 37, 38 intersections out of a total of 100 throws, and we do it for 2 toothpicks instead of 1. We will obviously get double of 38, 30, so we'll get about 76, 77, 78, around 80. We'll get double. So now that part is obvious, but that should hold, like the sum should become double, the number of intersections should become double, even if the 2 toothpicks are joined together. So even if the 2 toothpicks are joined at the end, and no matter what shape they are, whether they're straight or whether they're bent, it should double. And then if you add one more, it'll become 3 times the original value. If you add one more, it'll become 4 times, and so on and so forth. So then suppose we have n intersections out of a total of m attempts of a needle of length 1. Then if we increase the length of the needle to say a, which is a multiple of 1, then we should get n intersections, n into a intersections out of m attempts. Because like we said, you keep adding it and the probable value or the number of intersections specifically will keep increasing. So now suppose we take a toothpick of the form of a circle with total circumference and length as pi l, where l is the distance between the 2 parallel lines that we have used in the experiment. Now, if you look at the experiment and the situation very carefully, then you'll realize that in such a case, the number of intersections will always be 2. No matter what you do, the circle will always intersect a parallel line 2 times. So expected value or the probable value will always be 2 if you extend it over infinite observations. And then if you want to apply this to a toothpick of length t, say, then you multiply divide by t inside the probable value formula, like so, and then you apply the summation formula that we just saw previously, where we saw adding multiple toothpicks together, and you will get 2t by pi l as the probable value of intersections of a toothpick of length t.